Hi, I'm Ujash. I work in NTRG lab at UCLA with Professor Tim Fisher. My main project focuses on flash cooling for dynamic thermal management of high-performance electronic systems. High-performance electronic systems are a necessity for next generation of technology. Let's look at some of the current technologies that support our lives. For example, data centers. Our social media apps that we love so much, each of these in data center would require more than a 500 megawatts of power plant to support just one app. And on the other side, you have a lot of electric vehicles coming out with their full self-driving, with maybe a full self-driving capability, which has very complex controls and battery management systems. And so in those cases, you would have a heterogeneous packaging board in which your electronic system is maybe doing camera sensing, radar sensing, controlling the motion of your car, and a lot of other things from a very small place. And so these technologies are already pushing the industrial limits right now. So what happens when we want to go even further? And to do that, from a thermal perspective, we have two challenges. One is that to make these technologies like the data center or even our electric vehicles more energy efficient, we would need to pack these electronics closer together. Now, this leads to higher heat fluxes that we have to remove. At the same time, these electronic components are requiring more and more power, and they are very in a they require power in a transient manner, and so thus our cooling system has to adapt to these thermal requirements. Now, these two physical requirements are not sufficient unless you combine them with the help of a dynamic thermal control. If we take an example of Boeing Dreamliners that were grounded in 2013, battery thermal runaway was the main cause, and it could be solved maybe with the help of more sensors, or in the case of battery modules, you are not able to put temperature sensors within the batteries. In those cases, you need a much more data-oriented analysis of what's actually going within the battery. And so to predict that with just the help of outside temperatures that you can actually measure. And so these kind of technologies, these kind of thermal controls have become more and more necessary for the high performance electronic systems. And so our approach to this is currently called flash cooling, which is a two-phase pulsed cooling technique in which we introduce a liquid coolant into a low pressure environment. This throttling reduces the temperature of the fluid that goes into the flash chamber, where our heat is actually being removed from the electronic system. And so you can see that the heat fluxes that we can remove are increased not only with the help of a two-phase convection coefficient, but also increase in temperature gradient. At the same time, if we know how the heat transfer coefficient and the fluid temperatures behave with respect to time, we can integrate those data into a dynamic thermal control model and create an adaptive cooling solution for such electronic systems. To demonstrate this, we are collaborating with Chip Center in UCLA, which is headed by Professor Subbu Iyer, and they are developing a platform called Silicon Interconnect Fabric, which would enable uh, orders of magnitude more chips to be integrated into a small place. And so this will become very, if applied, for example, if applied for data centers, the processing would become much more energy efficient. However, this has the same problems that we discussed before. And so this is a perfect example of a system that we would like to cool with flash cooling. And so we are collaborating with Chip Center to actually cool their interconnect fabric. Now the CAD model that you see here, we are actually building this stuff with the help of multiple grad students and undergrads. And this is what motivates us to get into the lab and make this a reality. And that's probably what I do with, that's probably it.